Ignition sequence start.
Good morning, and welcome to a peek at the activity inside the International Space Station Flight Control Room at NASA's Johnson Space Center in Houston. These are the members of the team of flight controllers charged with keeping an eye on the safe operation of space station systems and helping the Expedition 64 crew members as they work through their schedule of activities for the day. Commander Sergei Ryzhikov and his American, Russian, and Japanese crewmates have had another busy week. They spent a lot of time on science research activities, as well as station maintenance and another spacewalk in order to complete an important upgrade to the space station's power system.
Houston Station on Space to Ground.
Welcome to Space to Ground. I'm Kayla LaFrance. From a successful second spacewalk to the first harvest of the year, it was a busy week on board the space station. This week, NASA astronauts Victor Glover and Mike Hopkins completed the second spacewalk of the year. The duo spent 5 hours and 20 minutes outside the orbiting laboratory to complete the work required to finish battery upgrades that provide power for the station's solar arrays. They also replaced several of the station's external cameras. This spacewalk concludes a 4-year effort to upgrade the batteries of the International Space Station's power system, replacing all 48 nickel-hydrogen batteries with 24 new lithium-ion batteries. 2 additional spacewalks are planned for the early spring. During the next spacewalk, Victor Glover will be joined by NASA astronaut Kate Rubins, and the pair will prepare the station for the future installation of new solar arrays to increase the station's existing power supply. This week was also harvest time on the orbiting laboratory for the ongoing vegetable production system, or veggie payload. The crew on board take turns growing and cultivating the scientific payload aimed at growing plants in microgravity. Astronaut Mike Hopkins noticed that some of the plants were struggling to thrive. Out of the different varieties of mustards and lettuces growing in special pillows covering clay-based growth media and fertilizer, 2 plant pillows containing outrageous red romaine and dragoon lettuce seeds were germinating slowly, growing well behind the other plants. In mid-January, it was decided that the crew would perform the first ever space transplant, transferring extra sprouts from thriving plant pillows into 2 of the struggling pillows. On Earth, this technique would be risky for plants in that delicate state. However, this first cosmic transplant was successful, and all of the sprouts were healthy and ready for this week's harvest. And that's Space to Ground for this week. Thanks for watching. We'll see you next week.
In their 2.5 months on the International Space Station, the astronauts who arrived on the Crew 1 spacecraft have gotten into the routines of living and working in space, and Mike Hopkins and Victor Glover have completed 2 spacewalks. Now, let's go behind the official biographies and let these astronauts reveal a few inner truths about favorite foods, the hardest part of training, and what's still on their space career bucket list.
Steak.
Anything with lots of zip.
Sushi. Princess Bride. Star Wars. The Replacements.
I like quirky movies. I'll go with Oh Brother, Where Art Thou?
The Moonwalk.
I like salsa dancing.
Spring. Always spring.
Spring.
I like places where you don't really have seasons, but I guess living in California, like going to college in San Luis Obispo, it felt like spring all the time, so maybe that's what I guess I like spring.
A good wedge of Parmesan cheese.
Yogurt. Greek yogurt.
Let's see. Ranch dressing. That's a kid thing. Tea. Tea, of course.
Tea.
Coffee.
Wastefulness.
Pet peeves.
People who don't use turn signal. Come on, is this so difficult? Be patient.
Don't be afraid, be bold.
Smile more.
spend the day on Mars.
So I'd probably run around and take lots of pictures.
Sand dune driving.
Hey, you're on Mars. That's good enough.
Don't worry, be happy.
I believe I can fly. I don't know, that just comes to mind.
Ooh, that's a tough one. Russian language.
Physically, it's spacewalk training, and mentally, it's Russian language.
Leonardo da Vinci.
Frederick Douglass.
And I don't know, actually. How about that?
Dark chocolate.
Sleeping during meeting.
I get to do so many amazing things in my life. When I have the time and can afford to do nothing, I really like to do nothing.
Oh, parent, by far.
Being a parent.
Parent, hands down.
Hopper.
IKE. It's an acronym, stands for I Know Everything. It's a reminder to never pass up a good opportunity to keep my mouth shut.
Walking on the moon.
To work on the surface of the moon, that's a dream, absolutely.
I want to spend a single day without any calendar events.
An officer in the United States Air Force.
Therapist. I'm good at listening to other person's talk. Believe me.
I'd still be flying, but the other thing I loved doing was working with students. Being in a classroom is one of the most meaningful things I've ever done, even to this day.
Karaoke.
Anything with my family.
If I could fly more, I would fly more.
Commander of time machine.
So the kids say it should be telekinesis, but I think to fly.
Teleportation.
To fly. I think we have a trend here.
I got a sweet tooth.
Probably Mexican food or Indian food. Or maybe Thai food. Good question.
I would say Moroccan and Indian.
Favorite decade? Wow. Favorite decade? Right now.
80s? Because the 80s.
1980s, because I was young and stupid, in that order.
The astronauts and cosmonauts on the International Space Station serve as the laboratory assistants for researchers on Earth who are looking into a wide range of scientific concepts, including some we'll have to master in order to return American astronauts to the moon as part of the Artemis program. For example, it'll be critical to understand how to interact with regolith, the fine particles of dust that cover the moon's surface. And we're using the Hermes facility to study how regolith particles move in microgravity over a long period of time.
If you look at asteroids or if you look at the moon, you'll see this layer of regolith covering the surface. So it's this fine particles, fine dust that covers the entire surface. So what's happening is the solar system is very dynamic, and we have asteroids and meteoroids moving around and impacting different bodies. So the surface is getting bombarded all the time. So you have this fine layer of fragments on the surface. So why would we want to study it, right? And why would we want to study it on the space station? There's a lot of interest in one day sending astronauts to asteroids, for instance, and we have already sent a lot of robotic missions to asteroids and plan to send more. And so every time we visit these asteroids, we learn more and more. And there's very diverse bodies of asteroids. Every asteroid seems to be different. And so we would need to understand how to interact with the asteroid surface. So if you're going to anchor to the surface of the asteroid, for instance, you need to understand how to interact with the regolith. So asteroids are pretty small bodies, and so they have actually microgravity levels of gravity. And so this is actually what you find on the space station as well. There's 4 experiments, and each one is a tube. So it's a clear polycarbonate tube about the size of a Pringles can. And so inside this tube, we have the asteroid simulants. And so this is what we're actually studying. And so the main piece of data that we're getting is the movement of these particles. So we have a camera looking at each of these tubes. Over the course of about a year, that cassette 1 will be up there, we'll get this basically time-lapse imagery of the particles moving. And so we're looking at the long-term effects of microgravity and what's happening to the movement of the particles. Also, something that we have on asteroids is vacuum, right? So we want to expose our experiments to the vacuum of space. So we actually have our facility hooked up essentially to a port to space. We did cassette 1, but the idea is that Hermes will be open to other investigators. So cassette 2, cassette 3, cassette 7, these will be other researchers that will apply to use Hermes to do research on asteroid regolith and granular material investigations. And we think that ISS is a wonderful place to study asteroid regolith, to study lunar regolith in general. So we're excited about the opportunities that Hermes will bring for researchers in the future.
Part of the science mission of the International Space Station is to take advantage of the weightless environment in low Earth orbit for research on technology that can benefit future exploration, or life on Earth, or both. For example, the station is home to a 3D printer that can make things and then recycle them and 3D print new things using the same plastic.
The In-Space Refabricator. Presented by Science at NASA. While 3D printers are technology that many people are familiar with, there's one 250 miles above us on the International Space Station, or ISS, that's unlike anything currently found on Earth. It's known as the Refabricator, a hybrid 3D printer that can recycle its hard polymer plastic numerous times to make new items. About the size of a dorm room refrigerator, the device is controlled by operators on Earth who oversee its manufacturing via video cameras. Nikki Werkheiser, NASA's In-Space Manufacturing Manager at Marshall Space Flight Center in Huntsville, Alabama, says, "Recyclers on Earth grind plastic pellets to create their products. But that grinding creates material shear, which prevents you from reusing that plastic again. It's no longer strong enough." For this technology demonstration, the company, Tethers Unlimited, developed a novel recycling process that doesn't require grinding, and that allows us to recycle the plastic multiple times. The ability to reuse the plastic over and over again is essential for long-term space exploration. Werkheiser says, "We can replace a lot of the things we need when we're orbiting above Earth. We just have them delivered on a resupply mission. But when you're in deep space, you don't have that option. You have to have the ability to make all the parts you might need and without having a large stockpile of extra materials." The Refabricator can even recycle plastic items not normally associated with Earthbound 3D printers. For instance, almost all of the materials that are delivered to the station are packed using foam or plastic bags. Both can be loaded into the Refabricator to deliver items such as a plastic syringe, an eating utensil, or a custom-made wrench. That ability limits the amount of backup materials you need to take with you on a long-range expedition. After all, in space, space is at a premium. The Refabricator's technology demonstration will be composed of 2 phases. During each phase, the Refabricator will perform 7 cycles of recycling and printing parts while on board the ISS. All of the items printed by the Refabricator will eventually be sent back to Earth for testing and analysis to determine the effects of repeated recycling on the material properties of the plastic. Werkheiser notes, "I'm very excited about this technology both in space and back on Earth. I can envision a day where you go to the grocery store and drop your water bottles and plastic bags into a Refabricator, and then select your new phone case, or a kitchen gadget, or the raw filament that you can use in your 3D printer at home." For more science from the International Space Station, go to www.nasa.gov/ISS-science. For more information about how the promise of future exploration is transforming today's technology, visit science.nasa.gov.
The astronauts on the International Space Station spend a good chunk of their time as lab assistants on experiments in a whole range of scientific disciplines, but they also devote time to sharing the experience of spaceflight with people on the ground, particularly when they talk with students and their teachers about science, technology, engineering, and math. In this installment of the STEMonstrations video series, astronaut and former classroom teacher Joe Acaba gets into the difference between kinetic energy and potential energy and demonstrates how one can become the other.
Welcome to the International Space Station. I'm astronaut Joe Acaba. Today, we're going to talk about potential and kinetic energy. Let's get started. Kinetic energy is the energy an object has because of its motion. An object can store energy based on its position. This is called potential energy. On Earth, imagine dropping an object from a raised position. As an object's altitude above the Earth's surface increases, its gravitational potential energy also increases. The potential energy stored due to its position is now being converted to kinetic energy. We also observe this with elastic potential energy.
Okay, new term. Elastic potential energy occurs when objects are compressed and stretched, or generally deformed in any manner, creating potential energy. Think of this bungee or a spring. Okay, Joe, what's next?
We pull back on the band and create potential energy. When we release the potential energy, it is converted to kinetic energy. Here on the International Space Station, we are still under the influence of gravity, primarily due to our position with the Earth. So when I have this ball on this ramp, normally back on Earth, I release the ball and it rolls down the ramp due to a change in its potential energy that's being transferred to kinetic energy. But as you can see, it doesn't happen here. So it doesn't mean we don't have potential energy. It just means we're not converting it at this time to kinetic energy. And why is that? Gravity is pulling us down, but we're moving super fast, and so what it is we're bending around the Earth in this perpetual falling motion. Thanks for joining me on board the International Space Station. We're sending it back to Earth so you can try your own experiment. See you next time.
The science, the technology, the preparation for exploration still to come, all part of the program of more than 20 years of continuous human presence in space on the International Space Station, and still counting. In that time, 242 different people from 19 countries have floated aboard and taken part in some of the more than 3,000 scientific investigations while getting humanity ready for future exploration out into the solar system.
This was once just a dream.
TTC go. TTC is go for launch.
2. Booster ignition and liftoff of Discovery and a team of explorers shaping their destiny.
An answer built by those who dared to ask. What if we were to channel humanity's knowledge and creativity into something truly revolutionary? What if we built a bridge between and above all nations? To jointly discover the galaxy's great unknowns. To endeavor to live and to work outside our planet for the benefit of all within. What started as an accord between two former rivals became a beacon of opportunity for the rest of the world.
We have ignition and liftoff of the Soyuz rocket, beginning the first expedition to the International Space Station and setting the stage for permanent human presence in space. You ready for visitors?
We live this dream aboard the International Space Station.
I understand it's good to have you there and adjusting to your new home.
Adapting to life in space. It's been a process.
For the past 20 years, over 230 astronauts from all over the world have worked tirelessly together, boldly performing pioneering research and high-stakes spacewalks in the unforgiving environment of space. In this unparalleled orbital laboratory, circling the planet at 17,500 miles an hour, thousands of groundbreaking scientific experiments from over 100 countries have led to discoveries unachievable in the confines of Earth. From 250 miles up, an unbroken chain of residents have shared their view and their research with a generation eager to understand this higher plane. The space station is a symbol of humanity at its best, a shining example of international peace and collaboration in action.
3, 2, 1.
Endeavour, this is Houston. You've completed a historic ride to the ISS and have opened up a new chapter in human space exploration.
And as we turn our gaze outward still, this International Space Station is a living testament of our collective strength and perseverance, where our human curiosity prepares for the audacious efforts ahead. We continue to bridge the distances between us and prove just how much more is possible when we dream together.
The men and women who live and work on the International Space Station take thousands of photographs of their home planet every year. Well, recently we asked the folks at the Earth Science and Remote Sensing Unit at NASA's Johnson Space Center to pick out a few of their favorites from 2020. Behold, the top 20 from 20. People from 19 countries have been aboard the International Space Station in more than 20 years of continuous human habitation. Hazza al-Mansouri of the United Arab Emirates was there in 2019 and says he has a new perspective on the power created when the nations of the world work together in space.
Recently, our country opened this opportunity to participate in a space program and to be part of international cooperation, to be part of the ISS. So I applied, and then through my journey I've been selected, and I've been fortunate to represent my country and also the whole Arab region, because I will be the first Arab on board the station. I read about Yuri Gagarin and Neil Armstrong, how they achieved their dreams and how they really reach the moon at that era. And then all of these things started the passion in me that I want to be part of this. I want to reach beyond the sky, to reach stars. Sitting at the top of the rocket and waiting for countdown, going to stars, and to join a lead team on board the station, doing a science, doing something for humanity is really something incredible, something that you want to tell it to the next generation. If you ask me like 2 years ago, can you be an astronaut? I will tell you I would like to be, but I think it's impossible. But now it's possible. What we did in our country and in our region after this mission is really impressive in terms of igniting the spark in the next generation. This is our job as an astronaut to let them know, to give them the experience that what we saw, what we experienced on board the station. You cannot experience here on Earth, from microgravity, from floating, and the view of the Earth from there. It's really amazing. It's something that's overwhelming. Looking at Earth from that angle, it's a different angle, different perspective, and you come back with appreciation what you have here on ground. I landed in Kazakhstan, but I felt like I'm back home. So despite the country that you land, you come back to your home, to our mothership, to our planet, to Earth. It's amazing how space unites everyone, despite from which country you're coming from, or from your religion or your background. It unites everyone. So it's really important to focus in this aspect and to focus in this front to exploring space, because somehow everything is dissolved. All these political issues, all borders dissolve. Despite from where we are coming, like from which country, our backgrounds, our religion, our objective is one, is for humankind.
If you want another look at many of the stories we featured today, you can always find them on YouTube and Facebook, where you'll also find lots of other great features on a wide variety of NASA topics. Be sure to look around. If you're looking for good conversation about human spaceflight, check out Houston, We Have a Podcast, our weekly show talking to folks involved in all areas of space exploration. Today, Gary Jordan continues the Mars Monthly series with a focus on the spacesuits astronauts will wear on those missions to come, in his conversation with EVA Office Systems Engineer Natalie Mary. Go to nasa.gov/podcasts for this week's episode and all our previous episodes. In fact, that's where you'll find the full library of all the NASA podcasts, which are all also on Apple Podcasts, Google Podcasts, and SoundCloud.